Welcome back, students. This lecture is part of our Growing Up with the Nemeth Code series. We'll be talking about those top-level applications that are used in advanced algebra and calculus classes. A lot of what happens in these classes will just be applying rules you've already learned in the leading up concepts, just to some new symbols, and that's very much how it's experienced by students as well. They've learned most of the code at this point, but because the math equations are so new, there will be some new looks to how things are put together or some new applications of those skills. One common structure for equations will be equations that include large signs. These could be sums or integrals, where a large sign with a lower bound and an upper bound is used to calculate some sort of formula. A sum is an equation made with a sigma, a capital sigma specifically. An example here is the binomial theorem. So you have x plus a to the power of n equals the sum from k equals 0 up to n of n pick k, x to the k times a to the n minus k. To Braille that, you need to know that that big kind of capital E looking thing is actually a capital Greek sigma. And to Braille that, we use the Greek letter indicator .46, then the capital, then the S because it's the Greek sigma. Integral is structured very similarly as an equation. It measures the area under a curve, and it has its own Braille contraction because it's such an important concept in higher math. The integral, which is kind of a tall, stretched out S shape, this one might be read the integral from a to b of g of x dx. So that's the derivative of x is what that dx is at the end. And the integral symbol is very much like the contraction. It's dots 2, 3, 4, 6. And we would use each of those in how we build those equations. To build them, just like in chemistry, we're going to deal with our subscripts and superscripts from bottom to top, and that's because it is how it's read, right? It's the sum from 1 to 5 or the integral from a to b. That's the range that you're applying this formula over. So when you Braille that, Brailing out the sigma equation, we've got the sigma sub 1 superscript 5 and then our .5 terminator to tell us to move forward. By not putting that .5 terminator in the middle, it lets us know that it's not a subscript followed by a superscript, but they're actually stacked right above each other after the sigma. And then whatever the formula is comes at the end, in this case x sub n. Integral, same thing. I'll start with my integral, do the subscript first for the lower bound, then the superscript for the upper bound, and then terminate with a .5. Then I'll put my formula after that, including the dx at the end. There's another way to write these in print specifically, that instead of it being from a subscript to a superscript, it might be actually written with the lower bound underneath the symbol and the upper bound directly above the symbol. And if that's the case, then we're going to use our directly over and under formula, where the .5 is going to go ahead of the term to be modified, that sigma or that integral or whatever the large thing is. You can even have a large pi or some other things. And the rest of the equation comes after. It's hard to get that print to show in the PowerPoint in an accessible format, but in general, it's something like this, where you've got your big summation or your big integral, and those lower bounds, instead of being subscripts and superscripts after it, are just written fully underneath it and fully above it, and then your formula comes after. So to Braille it, .5 multi-purpose indicator at the front, the sigma that's being modified. Then we use our directly under symbol and write whatever the underneath part is, our directly over symbol and whatever the on top part is, and then our terminator for that over under pattern of writing things, and then the formula that comes after it. Again, like many things in math, as the TVI, you're going to transcribe whichever style the print was. If the print was over under, Braille it over under. If the print was a subscript and superscript after it that are stacked, Braille it that way after. So your students have access to seeing it written both ways and recognizing those as the important math. When your student goes to work the equation, they may have a preferred way of writing it, and the mathematical meaning of the two formats is exactly the same. So if they want to write it as a subscript and superscript, even though the problem is presented directly over and under, that should be totally fine because it means the same thing. It's just a different notation style, and one is more efficient in Braille than the other. There are some other common underneath things like a limit that has a boundary, it's an approaching, where the n to infinity would be written directly below the limit, or I to infinity is directly below the limit. When it's written directly below the limit, again, you'd use that .5 first, whatever the term or portion like LIM is that is being modified by having something directly under it. Use that directly under indicator, .146, write everything that is underneath the limit, put the terminator, that kind of ER shape, and then go on with your problem from there. In the context of limits, the directly below is really the only option. You can't write that as a subscript after. The spacing gets really confusing about what is part of what, and that's not a common way to write it in math. In upper math, you'll also see some special functions. If you have a function of f of x, and a function that's g of x, so you could put x into either one and they behave differently. Maybe one of them squares it and the other one cubes it. They would be defined there. Then you'll learn to take, or your students will learn to take, the composite function of another function, right? So the composite f of g of x. And that really just means that you're calculating g of x and then doing whatever f of x is to the whole formula g. That composite is a hollow dot in math. So there's like a little circle in the middle there. It's not really an O, it's a hollow dot. And so it's brailled as a hollow dot, .4616. That is something you should recognize from the degree sign, but in this case, it's not a superscript because it's not raised. It's just the hollow dot in the middle of the line. And so when brailling that equation, you would need to know that symbol. If you are squaring a function, be sure that you remember to put the .5 multipurpose indicator after your power before you go into the function itself so that you return to baseline as you move forward. Those are some common formats. At this point, you'll need to be sure that you know a range of Greek letters. I have a table of them here showing what the print looks like compared to how it's said. If you're not familiar with Greek letters, especially if you didn't do Greek life in college and didn't do math at a high enough level recently enough to remember it, you might need a refresher. These are some of the most common ones used in math. So I've got theta, beta, gamma, delta, lambda, phi, omega, sigma, and pi. There's also a capital form of pi that's not quite as squiggly. And then the Nemeth examples of how those are written. The Nemeth examples follow pretty logically. So once you know you're reading in Greek because it's got a 4-6 prefix, if you're in a class, you're in a physics class and the teacher is saying things about theta and delta, and maybe your student hasn't really learned the Greek alphabet, because at what point before 11th grade did you learn the Greek alphabet? Never. But your teacher's going to say one or two of these Greek letters at a time in a unit. Greek letter indicator TH and Greek letter indicator D, your student will not have much trouble figuring out which of those is delta and which of those is theta. So this is a great level in the Nemeth learning that a student listening to class with their sighted peers and having appropriate Braille materials under their fingertips at the same time is going to have a good ability by this point in their Braille reading career to be filling in new letters from what they're hearing the teacher say, whereas their sighted peers probably cannot figure out which one is theta and which one is delta from seeing both of them and hearing their teacher say it, they'll be putting that together because their teacher says it and writes it on the board or on the overhead or on the smartboard at the same time so they can see it and hear it. Your student is often at a little disadvantage with that because the teacher isn't showing them one Braille term at a time. They have their whole Braille textbook page available to them while the teacher is talking. But because the Nemeth is so logical, our Greek delta is just Greek D. Our Greek theta is just Greek TH. We can figure out which one goes with which with a little more advantage than sighted students can figure out which different letter shape goes with what's being said. It's a unique experience when the blind student needs less individualized coaching on something than their sighted peers do. So enjoy that moment with your student if you see it come up. Students at this level will take derivatives, take second derivatives, which are marked with a prime tick after the function name. That tick you've learned before. You've seen it in things like A prime, B prime, C prime in geometry. It's the same prime tick when you get to derivatives. There's not a different symbol for it. It's the same one used again. Remember that that's a .3 in Nemeth, which is different than what it would be in UEB. There are other advanced symbols that you'll only use when you're using them. I would not propose that sighted TVIs need to memorize every possible contingent symbol. In fact, there are a lot of Nemeth math symbols that you'll never use simply because there was a Nemeth symbol created for every way that math was being written in the 50s, and math nomenclature has standardized. How it's written in print is now much more consistent than it used to be before the advent of computers. And so because it's so consistent now, there are things we use all the time, and there are alternate ways of writing that same math that there exists Nemeth code for that simply you would never see that written in print because nobody writes the math that way anymore. But with those higher level specialty symbols that you use now and then, I encourage you to know where to look them up, and that will serve you really well in your career. So if you're looking at the Nemeth at a Glance book from Texas School for the Blind, you'll want to see pages 77 through 83 for a reference to other high-level symbols. You can always find any Nemeth symbol in the official Nemeth codebook. It's available on the BANA website. You can get to it with your internet connection free of charge anytime, anywhere. If you're using the NFB Nemeth textbook that walks you through lesson by lesson, these extra symbols will appear in chapter 13. It's useful, my tip to you as a TVI, when you get a student who is working at that high level of math, it's a really good idea to make yourself a reference key, kind of like in third grade when you were learning spelling words or teaching kids spelling words and they make their own personal spelling word book that they add spellings to as they encounter them. Make a reference key for math symbols as they come up in that student's curriculum. Then you'll have an easy one-page at a glance where you can look up things that are frequently used in their textbook if they get stuck or start to forget what they were. And you won't have to be searching through the code book over and over again for the same symbol. So just jot notes as you're going through it with a student, and you will very quickly have the 20 or so new symbols that you need for your school's Calc 1 class or whatever it happens to be. So I think that's a really efficient way to cope with the wide range of symbols that there can be at this level and focus in on just the ones that are relevant to you and your student at that time. Again, there won't be a ton of new rules at this level. There will just be new symbols operating in the same way that you've practiced over and over again and that your student has hopefully been using over and over as they've grown up with the Nemeth code in their classes. Until next time, happy Brailing!